we're going to take a look at some systems word problems today. And we're going to see that primarily when we're solving systems word problems, they're in standard form. So let's go ahead and start with our first. Let's just start with a quick review in terms of the three different types of elimination problems. Okay, so the first one, I see that I have the opposites. So I see that I can eliminate right here, make those go away, add down 3 plus negative 6. That's a negative 3y. 12 plus negative 15. That's negative 3y would be negative 1. And then to substitute in, I put in my negative 1. I'm going to use line 1. 2x minus 3 is 12. If I add 3, I get 2x equals 15. And x is going to equal 7.5. And you can get decimals. There's nothing wrong with decimals. We normally don't end up with too many decimals as we're working on word problems unless we're talking about money, but it can happen. So my answers are 7.5, comma, negative, whoops, that's my problem, positive 1. Let's try that again. I added a negative in there. So 3y equals negative 3. Y is positive 1. Okay, so subtracting 3, I'm still going to get a decimal, but I get 4.5. So 4.5, comma, positive 1 is my first solution. Okay, now let's take a look at this next one. So this one, I see that things are the same. So that means I need to multiply one of the lines by negative 1 to eliminate. So I have negative 2, a positive 2, and a negative 8. And I see here's my additive inverses. And from there, I can solve like always. So negative 3 and negative 2, that's a negative 5. 12 plus negative 8 is 4. So x is going to equal negative 0.8. And if I substitute in, I have 2 times a negative 0.8 minus 2y equals 8. So this is negative 1.6. So I'm going to add 1.6. So again, it doesn't make any difference if they are decimals. The process does not change. I'm adding 8 plus 1.6, and then I need to divide by 2. So y is going to equal negative 4.8. Excuse me, so I have negative 0.8 and negative 4.8. Okay, now the third one was if I had completely different numbers, but I see that there's a negative 1. So this is the line I'm going to multiply. So if that's a negative 5 and I see a positive 5, I know I need a negative 5. So I'm going to multiply by 5. 5 times 3 is 15. 5 times negative 1 is negative 5. And 16 times 5, that brings me to 80. Again, that one is gone. Here are my numbers that are left because these are gone. So 19x equals 92. 92 divide 19. X is going to be 4.8. So I have another decimal. So 4 times 4.8, I'm going to use the bottom one this time. So 4 times 4.8 is 19.2. I'm going to subtract 19.2. So 5y equals negative 7.2. So 7.2 divided by 5 is going to be a negative 1.44. So I'm going to round that off to 1.4. So I have 4.8 and negative 1.4. So the process does not change. Okay, but these are the three different types. Either the opposites are already there, the same numbers are there, or I actually have to multiply by a completely different number to create the opposites. Okay, let's look at our first word problem. So we're looking at ax plus by equals c. Okay, so there's two things in a total. So John and I went to the baseball game. I bought 2 sodas and 3 hot dogs for $14. John bought 4 sodas and 2 hot dogs for $16. And they want to know what is the cost of a hot dog and the cost of a soda. Okay, so let's think about what 2 things I'm buying and the order they're in. So the first thing I see is sodas. So that's going to be my x. And the second thing I'm buying is hot dogs. And that's my y. So my first equation is 2x plus 3y equals 14. The second equation is 4x plus 2y equals 16, coming from my problem. Okay, so let's take a look at what we have. Do we have anything that is already the opposite? Nope, I do not. Do I have anything that is the same? Nope, I don't have that either. So that means I got to multiply one line. Well, let's see. Can I make a 2 a 3? No. Can I make a 2 a 4? That I can do. So if I see that this one is a positive 4x, I need a negative 4x. So what am I going to multiply the 2 by? Well, negative 4 divided by 2, that's negative 2. So negative 2 times 2, negative 4. Negative 3 times 2 is negative 6. And negative 2 times 14 is negative 28. Here are my additive inverses. They are gone. 2 plus negative 6 is a negative 4. And 16 and a negative 28 leaves me with a negative 12. So I'm dividing by negative 4. Y is 3. Y is 3. Okay, let's go back to our first problem. Throw in my 3. And let's solve for x. So 3 times 3 is 9. Let's subtract our 9. 2x equals 5. And let's divide by 2. X is equal to 2.5. And that's okay that we get a decimal because we're talking about money. Okay, we're talking about money. So we have 2.5 comma 3. So which one of those is the cost of the soda? Well, sodas are X. That tells me my soda is $2.50. And my hot dog is my Y, so it is $3. It is $3. Okay, let's look at this one. So the school that Lisa goes to is selling tickets to the annual talent show. On the first day of the ticket sales, the school sold 4 senior citizen tickets and 5 student tickets for a total of $102. So I think I'm going to underline this because I think that's important. The school took in $126 by selling 7 senior citizen tickets and 5 senior tickets. What was the price of each one? Well, I see 2 things. I see senior tickets and I see student tickets. So that's my X and my Y. My first equation would be 4x plus 5y equals 102. The second equation would be 7x plus 5y equals 126. Okay, so let's decide which type do we have. Do we have opposites already? No. Do we have things that are the same? Yeah, we do. We have a 5 and a 5. So I'm closer, but I know I need to multiply one of these by a negative 1. So let's multiply the top line. So negative 4x, negative 5y, and a negative 102. And let's go from there. So those are gone. 7 minus 4 is 3. 126 minus 102, that's 24. Divide by 3. X is 8. X is 8. Okay, let's substitute in. I'm going to go ahead and use the top one. Putting in my 8. 4 times 8 is 32. If I'm solving for y, I'm going to subtract my 32. 5y equals 70. And to finish, I need to take 70 divided by 5. Y is 14. So my solution is 8, 14. Okay, so I need to figure out what is the price of a senior ticket. Well, let's go back. Senior said X. So my X value is 8. So the cost of a senior ticket is $8. The cost of a student ticket is $14. Okay, one more. And then we'll cut you loose to work. So this time we're selling tickets to the annual dance competition. So on the first day of ticket sales, the school sold 3 senior citizen tickets and 3 child tickets for 69. So I know I've got seniors and child again. I'm going to go ahead and write that down. And my first equation, 3x, 3y, 69. The school took in $91 on the second day by selling 5 and 3. So 5x, 3y, and I have another total. Okay, so this one is very similar to the last one. I see that I have the same numbers, positive 3 and positive 3. So I'm going to multiply by the negative 1. So negative 1 times 3 is negative 3 and negative 3 and a negative 69. Cross those guys out. 5 minus 3 is 2. And 91 minus 69 brings me to 22. Divide by 2. X is 11. X is 11. So let's go ahead and use the first one. 3 times 11 is 33. I'm going to subtract 33 from both sides. 3y equals 36. Dividing by 3, y is 12. So my solution is 11, 12. So how much was the senior ticket? Yeah, the senior tickets are $11. How much is the adult ticket? Or the child ticket. Child ticket is $12. Those were much closer together in price. Okay, so let's see what you can do with these. Make sure and show your work. And let us know if you have any questions.